Okay, so this is the last part that's going to be on this next exam. Um, well, there's two more parts. So radical equations is one of them. You do need to be able to solve radical equations. Make sure that when you're doing these, that you are isolating your radical first, right? So like in this particular case, you have this extra plus x on here, which would need to move to the other side first so that you can isolate the radical and then do your squaring of sides so that the radical goes away on the left-hand side. If you do it before, then you would have to do a FOIL process here. So make sure that you isolate one of the radicals first and then go about foiling this other side. Alright, so I would get 9 minus 6x plus x squared when you FOIL this out. 3 times 3 is 9. You would get negative 3x, and negative 3x gives you the negative 6x, and then negative x squared is positive x squared. From here, since I have an x squared, that tells me this thing's going to be a quadratic, and so I'm going to get everything onto one side. I always move to the side that makes my x squared positive just because I prefer that. There's no actual rule that says you have to do that. It's just something I prefer. Alright, so when I do that, we're able to factor, or from this point you would try to factor this one. I believe factors x minus 5, x minus 2. And that's still equal to 0 because negative 5, negative 2 makes positive 10. And negative 5 plus negative 2 makes negative 7. And then x is equal to 5 and 2. Now do remember that with the radicals and stuff, you do have to double check to make sure that the solutions that you get are not extraneous. So like when I plug in 5 minus 1 would be 4, square root of 4 is 2, and then 2 plus 5 gives me 7, and 3 minus 5 gives me negative 2. So if you look at that one, and I'll write it out here so you can see it, it's plus 5, and I'm just plugging that 5 in. Right, that would give me square root of 4 is 2, which would give me 7 equals negative 2, which is not a true statement. So 5 here is extraneous, so that's not part of my solution set. And then check the same thing, so 2 minus 1. Alright, so square root of 1, sorry, so 2 minus 1 is 1, square root of 1 is 1, plus 2, which is equal to 3 minus 2. Oh, I wrote this wrong. I'm sorry. I was like, neither one of those works. That doesn't work out. I am so sorry. This minus x was from this minus x when I crossed those out. So let me double check those numbers. I'm so sorry. All right, square root of 5 minus 1 plus 5 just equals 3 is what that was supposed to be. The original problem didn't have minus x here. This is from when I moved that x over. So the original problem was square root of x minus 1 plus x equals 3. So sorry. So anyway, so back to checking. So square root of 4 is still 2 plus 5. All right, so that one still works out so that it's extraneous because 0 to 7 does not equal 3. For the other one, square root of 2 minus 1 plus 2 equals 3. Square root of 2 minus 1, that would be the square root of 1, which is 1 plus 2, which equals 3. And 3 does equal 3. So the 2 works. So if they were asking you for what the solutions to this particular problem is, you don't include the 5 at all. The solution would just be the 2. Okay, so x equals to 2 there. You also need to be able to handle if you have more than one in the same equation. So if you have multiple radicals, there's a few of them here. I'll do a couple just to kind of show you. The important part is that you first isolate one of them. It doesn't matter which one. Pick one that you want to isolate, but isolate a radical first and then go from there. So let's say I'm going to move this one over. So I have it isolated on the right hand side. So from there I will square both sides. Right, 2 squared is 4, and the square root of x squared is just x, because the radical there does cancel. And then on this side I would get 4x minus 3. Here in this particular case, my variables cancel, and I end up with two numbers that are not the same, which means there is no real solution for this. Okay, so there's no solution for this one. You can use the little empty set thing, which just means no solution, or you can write out no solution, or just don't put it equals 0 because that's not the same thing. Let me show you another one. So like square root x squared plus 3x plus 6 minus square root x squared plus 3x minus 1, all equal to 1. So same thing, I have two radicals, so I need to get 1 by itself on one side. So I'm going to move this one over to both sides, right? So move it over. That whole entire thing. Sorry, I ran out of room there. And then when I square both sides here, make sure you FOIL on that right-hand side. So on the left-hand side, I would just get x squared plus 3x plus 6, which is equal to. Now on this side, I have to FOIL. So I would get 1 times 1 is 1. 1 times this is just this, and then 1 times that again. So I would end up with 2 square root of x squared plus 3x minus 1s. Right, and then when I square this thing or multiply by itself, that would get rid of the radical, and I would have x squared plus 3x minus 1. Okay, so I have 2 still in the radical, and then here it just cancels out. So from here, I need to clean all of this up, and I'm going to have to isolate that radical since I still have one left, just by getting everything over to the other side. So I'll start by moving my x squared over. Those happen to cancel, minus my 3x over. Those also canceled. They don't always, but in this particular case they do. So plus 1. And then I also had this one out front, so minus 1. Okay, so what that leaves on the left-hand side here, 1 minus 1, that's obviously 0. So I have 6, which is equal to 2 times x squared plus 3x minus 1. Since this is 2 times this, we're going to go ahead and divide that 2 over. Right, and then from here, go ahead and square both sides. Now again, I have an x squared still here, so that tells me that I have to look for factoring or quadratic formula to finish this out. So I'm going to minus the 9 over. So 0 is x squared plus the 3x minus 10. Okay, factoring that out. X plus 5, x minus 2. Alright, multiplies the negative 10, adds the positive 3. So x would equal negative 5 and positive 2. But of course, again, you have to go back and check these into the original equations to see if they actually work. So going all the way back up here, to the original, this was just equal to 1. Let me not make the same mistake twice, right? So I would get the square root of negative 5 squared is 25. 3 times negative 5 is minus 15 plus 6. And then that's minus the square root again of 25 minus 15 minus 1. Okay, so that would be a minus 1. And that should all equal to 1 if it actually works. Alright, so then simplifying, that would be the square root of 16 minus the square root of 9 equals 1, which would be 4 minus 3, which equals 1. And it does. So 1 equals 1. So x equals negative 5 works. Need to do the same thing with the 2. We need to check it. I'll do that right here in the little side. So square root of 2 squared is 4. Plus 6 minus square root of 4 plus 6 minus 1. Alright, and that thing should equal 1 if it is true. So 10 plus that's 16. Alright, 4 plus 6 is 10, minus 1 is 9. And that should all equal 1, and 4 minus 3 does equal 1. Alright, so both of those in this particular case work. So negative 5 and 2 are both solutions to that particular problem. Okay, you do have to check. Remember, you always need to check for extraneous. Anytime you start squaring things, you get rid of those negatives, and so you could end up with solutions that mathematically they calculate out, but they don't actually work when you go back to the original problem. So make sure you can handle those types of things. That was 9.3.2. And then one of the other things I wanted to look at for this section was the inverses. Finding inverses of functions. Sorry for all the movement on the camera. I'm having to hold the phone and do it. Makes it a little more difficult. Anyways, so find the inverse. So like number 6 here in our exercise said f of x is equal to 9 plus the square root of 4x minus 4. All right, oops, sorry. Make sure this camera actually shows what I'm talking about. So when I'm doing the inverse, you can switch the x and y at the end or at the beginning. I prefer to switch them at the end. So this is my y and my x. So I'm going to switch that over, make that my x, and make this my y, and then I'm going to solve for y. Okay, so I'm going to take this whole thing and I'm going to solve this thing for y. So I would minus the 9 to the other side. So I get x minus 9, which is equal to the square root of 4y minus 4. And then I would square both sides. Okay, so I get x minus 9 squared is equal to 4y minus 4. Okay, a few different things you can do from here, but I'm going to go ahead and just add the 4 over. I'm going to go ahead and expand this so that I can add the 4 into that equation. So this here would give me x squared minus 18x plus 81. All right, and then I'm going to add the 4 over. So x squared minus 18x plus 85 is equal to 4y. All right, and then you can divide this stuff by 4, which that itself would work. All right, so that inverse function, let me write it in the proper notation, right, with that negative 1 up there. So the inverse function would be the x squared minus 18x plus 85 all over 4. Okay, so it would look something like that. When you're looking at those, I think, right, this one didn't ask you to identify what the restricted domain is. Do keep in mind that on the original domain,